Morning grade 12, you're speaking to Kosa Tandi. I am going to be doing trigonometry with you today. This is a very nice, simple and focused topic. It will be part of your paper 2 in final examination. The reason we selected this trigonometry is because it has more marks than other topics in paper 2, or compare with the other topics in paper 2, and this one can grant you the pass, at least which the national department want you to pass with. So let's look at the questions that most of you are struggling with answering and see how we can try to grab marks out of it. Okay, this question normally starts from question 5, question 6 and question 7. So we'll deal with them playing around them with from different previous question papers. Question 5, the first one that we have selected, is in this format. So let's start with question 5. It is previous question papers, question 5. Okay, the instruction that was given to us was in the diagram. So there is a diagram there. Let us draw the small diagram we're talking about. So this is the question paper we are looking at. And now let's draw the small diagram they're talking about. In the diagram, which is a Cartesian plane, there is a point P, which is there with coordinates K and 1. Okay, and there's a theta there, which is going in there. The radius is the square root of 5, and there's a point there they've written being R. And let's read the statement. They said in the diagram P, there's P, K, and 1 is a point in the second quadrant. So this is our second quadrant. And we have a radius with the square root of 5. From the origin, this is line OP. And they're giving us the positive x-axis of the obtuse angle theta. So you can see ROP. So this is ROP, this is the angle, it is theta. Now the question number 1, 5.1.1 says, calculate the value of K. So looking at K actually represents the x-axis point. So it means we're going to try and construct a right-angled triangle. Remember folks, the moment you have to deal with a right-angled triangle, you can use Pythagoras theorem, you can use the ratios of trigonometry, which is the definition. Now with this one, because we can quickly label them in this way, K represent X, so we can put it here, and 1 represent Y, which we can put there. Now in this one, when they say to you calculate the value of K, you can see you have R, you have Y, you are looking for X, so we can use Pythagoras theorem. So let's answer that one. It's 5.1.1, and it means we are going to say, okay, R squared equals Y squared plus X squared. This is our theorem of Pythagoras. Okay, Pythagoras theorem says the longest side squared equals to the sum of the adjacent side squared as well. So our R is the square root of 5, so we're going to say square root of 5 squared, and our Y is 1. We are looking for X, which is K. Okay, we can substitute that to be K so that we remember what we are looking for. And simplify, the square root of 5 squared will give us a 5, and 1 squared will be 1 plus K squared. If we do the algebra there, we'll have 4 equals K squared, and therefore K is equals to plus minus the square root of 4, which makes K plus minus 2. Now look at the Cartesian plane. It's on the second quadrant, whereby X is negative. So we are going to choose the one for negative, meaning that K will be equals to a negative 2. So we can say this is now a negative 2. Okay, we have found the solution for the first question with just simple Pythagoras theorem. Now this statement comes and say, and they bold this statement usually, they say, without using a calculator, calculate the values of, and they start listing them all. You must bear in mind that calculator is not used there. That is your instruction. Okay, that is 5.2.1. And in 5.2, that was 5.1.1, this is 5.1.2. There's number A there. Number A, they want us to calculate what? Tan theta. Now, tan theta, we can find it by saying it is opposite over adjacent. So it is opposite over adjacent. It's going to be y over x. So it means it's 1 divided by negative 2, which gives us a negative 1 over 2. That is how we find our tan theta. Number B says we must calculate the value of cos 180 plus theta. Now folks, remember 180 plus is on the third quadrant. It's here. So 180 plus theta was supposed to be there. So it means we're going to simplify this first by putting a negative cos theta. Remember to keep that negative with you and look for cos theta, because that's what we are talking about now. But the 180 plus theta, it has been represented by the negative. Now cos theta there will be now adjacent over hypotenuse, which is x over r. So it's going to be a negative 2 divided by the square root of 5. There's a negative outside the bracket. Multiplying them will give us a positive, so that is 2 divided by the square root of 5. This is 2 marks. 1 mark will be for the simplification, and the other mark will be for the location of the solution. Okay, and the third one, it says, now they are actually trying to confuse you. Do not focus on the confusion, focus on the information that you know, logic, and that's what we need. They said to you, this is 5, it is number C, still on 5.1.2. They said sine theta plus 60, and the question was, you need to calculate without using the calculator the value of sine theta plus 60. Now if you look at it, there's nothing that you can do really in terms of that until before you expand this one. You must expand it. How do we expand? Quickly run to your formula sheet. This is your formula sheet. Remember, the formula sheet will be there for you. Run to it and look at something that looks like this one. There we have the compound formula, sine alpha plus beta, and they expanded it. So you're going to expand it like that, looking at the formula sheet. So this is going to be sine theta cos 60 plus sine 60 cos theta. That is your expansion. You need to bear in mind that the expansion for sine, it does not change the sign, but it changes the ratios, and that's what it does. Now you can deal with this one, because sine theta, therefore, you have it there. Sine theta, it is opposite over hypotenuse. So it's going to be 1 divided by root 5. What is cos 60? Cos 60 from the special angles is 1 divided by 2. And what is sine 60 from the special angles is root 3 over 2. While cos theta, we know that it is going to be negative 2 over root 5. So that it's negative 2 divided by root of 5. So this is what we are having at this moment, because cos theta, we just found it, cos theta is adjacent over hypotenuse. Okay, folks, let's multiply this out. We'll have 1 divided by 2 times the square root of 5 plus, so we're going to say negative times positive give us a negative 2 times the root 3 divided by 2 times the root 5. Now having them like this, it simply means that you need to look at the lowest common factor. Lowest common denominator there is 2 root 5, 2 root 5. Folks, 2 root 5 can be written as the square root of 20. So you can put the square root of 20, which now had satisfied the form that they wanted you to do. Because they said, write this in the form of a plus b divided by the square root of 20. Can you see that? You must simplify this one such that it accommodates this one. You calculate this one to be in this form, not exactly with a and b, but the form. So the denominator, therefore, it has been covered already by doing this. Okay, then you add the numerator. This will be 1 minus 2 root 3. And in that way, you have your a and your b and your root 20. Then they give you 5 marks just by doing this one. Folks, this is one of the questions that is unexpected, and most of the time you won't be taught this kind of questions. You use logic to get it right. Okay, and that is the end of the question number 5. Thank you. Okay, matrix, let's now continue with this trigonometric. Very nice, straightforward and simple questions. This is the questions that is coming at the first question that is given as trigonometric. Sometimes it's question 5 and sometimes it's question 6, depending on the question paper. Now, look at this question. The first one that we have done, the diagram was drawn for us and was straightforward. Now the diagram is not there. What are they saying now? They say, if you are given cos of 2 theta being equals to negative 5 over 6. So it's still on question 5. So let's write that question down. We are still in question 5. Okay. And the information, therefore, it says, if cos 2 theta is equal to negative 5 over 6, and it's not ending there. They said where 2 theta, it is in a boundary of, or is an element of 180 degrees and 270. So you need to remember where that is. 180 to 270, it is on the 3rd quadrant. Because when we draw a Cartesian plane, we read 0 to 90 to 180 to 270 and complete it at 360. So that's where your 180 is, and that is where your 270 is. So whatever you're talking about, it is between this 3rd quadrant. Okay. Now they said calculate without the use of a calculator. So we're not using a calculator again, but you have to find the value of something else. So when you see these kind of questions, just before you do anything, you must represent this information in your diagram. Always. So this is the diagram on a Cartesian plane. What are they saying? Whatever it is going to be on the 3rd quadrant. My diagram is going to be a right angle, the triangle there. Okay, where is the angle 2 theta? The angle 2 theta we are talking about is the one that is there. So this is where 2 theta is, this angle there. Okay, now we're given that is going to be equals to a negative 5 divided by a 6. Now, go back to our basics. Remember that if you had a Cartesian plane with a right angled triangle with r, x, and y, where this is theta, your cos of theta will be adjacent over hypotenuse, meaning it's x over r. That means that negative 5 represent your x, while 6 represent your r. So that's what you're going to do on the sketch. You must label them as such. Look at this. Your negative 5, it's going to be in the x-axis because represent x. And your 6 is going to be the r, which is your hypotenuse. What are you looking for now? It is your y. Your y is now missing. You need to find the y. And before you can even look at the question, by representing that is telling you that y is missing, immediately so use Pythagoras theorem and then find the missing side. So let's do that. If we use Pythagoras theorem, we'll have, remember it's r squared equals x squared plus y squared. So our r is 6 and our x is negative 5. This is equals, and we are looking for y. And this is going to be 36. That's 25 plus y squared. So 36 minus 25 will give us how much? So this is 36 minus 25 equals y squared. Y will be equals to the square root of, remember it's y, so it should be plus or minus. The only thing that comes positive, it is always r, because r is a radius. Radius cannot be negative. So with y and x can be negative depending on the side where you find it. In the 3rd quadrant, both x and y must be negative. So you can quickly run to your calculator and then make sure that you get it right. So here we go. We're having the square root of 36 minus 25 and gives us the square root of 11. Now you go to the Cartesian plane and check. In that means y is going to be equals to negative the square root of 11 because we're on the negative side of the y. So there your y, therefore it's negative the square root of 11. We haven't yet looked at the question, but you have done this all, and it consists of marks as well. By showing this, you have some of the marks already before answering the question. The question number 5.1.5.1.1, so it's 5.1.1, says that we have to calculate without using the calculator the value of, in the simplest form, of sine 2 theta. So that's what you're going to write. What is sine 2 theta? Remember our angle is 2 theta. So sine 2 theta, it is opposite over hypotenuse. So it's going to be a negative the square root of 11 divided by 6. And this one is 4 marks. Folks, the 3 marks will have run through this 2 that you have started with, and then the other marks will come to that part. Okay, 5.1.2. So let's go to 5.1.2. They said you must find what? Sine squared of theta. Sine squared theta. Folks, bear in mind that your diagram does not have theta, and you cannot grade theta in the diagram. So you must do something to get to that theta. How do you do it? Your formula sheet is a key. Go to the formula sheet, check what is it that can relate to the sine squared of theta in terms of 2 theta. So somehow you'll have to change it and put it where it's supposed. So your formula sheet here and information is very important. So let's look at it. If I look at sine squared theta, I can try to change it using anything. For now, I can go to the formula sheet and check cos 2 theta. Remember, it has 3 things. So it can be cos squared theta minus sine squared theta, or it can be 1 minus 2 sine squared theta. So if I use 1 minus 2 sine squared theta, have you guys realized that already? I have what I'm looking for, sine squared theta. What I need to do is just to make it the subject of the formula and get to the solution. What is cos 2 theta? Cos 2 theta was given to me as negative 5 over 6 there at the first statement. So that's what I'm going to do. This one I'm going to substitute it by negative 5 over 6, and I have 1 minus 2 sine squared theta. Remember, we're looking for sine squared theta, so this is our key where we want to go to. Okay, so we'll have to work it out, play it around until we have sine squared theta equals to something. So this is, let's take out the 1 to the other side. So it's minus 5 over 6 minus 1 equals minus 2 sine squared theta. We still don't need the minus 2, so it means we have to take it to the other side as well. So we are going to divide both sides by that minus 2. So if I divide that by minus 2 and divide the whole thing by minus 2, the minus 2 will cancel with the minus 2. Then I remain with the sine squared theta. With you guys, you can go in and then use a calculator. Then you get what sine squared theta is equals to in terms of the. Punch it as it is on the calculator. Just use your fraction buttons twice and it will give you what you are looking for. So it's, let me quickly do it on the calculator so that we don't waste time. Remember, calculate is one of the things that saves time. So it's giving me 11 divided by 12. So that means that sine squared theta is equals to 11 divided by 12. They just tricked you, knowing that you'll end up taking this and use 2 theta and forget that you are dealing with theta. So you must first change it to this, which is part of your information sheet, and then come to the solution as it is. So this is the answer. Sine squared theta is equals to that. So with 5.1, we are kind of done with it. So this was 5.1. Let's go to 5.2. And now 5.2 is out of what we were doing. 5.2 is something else. Let's look at the question. Folks, this one is focus, concentration, and some of the information that you have to revise. Now, this is what makes trigonometry looks difficult or complicated. It's because most of the information you must try to bring it on by the time you are writing. So you must try to practice it as much as you can so that this information stick to your head. Okay, now let's write the question down. In this one, they say simplify. Now, simplify simply means do something until you can't do anything. You must simplify this to a single trigonometric ratio. Whatever you do, at the end, you have to have one single trigonometric ratio. Folks, single trigonometric ratio means you have to end up your answer with either tan of something, cos of something, or sine of something. Not 1 plus, 1 minus cos, 1 minus tan. It has to be one term. So it's either it has been divided becoming one term or something like that, but you cannot have 2 terms. That is the meaning of one trigonometric ratios. Okay, let's write the question down. They said is sine, it is sine 180 minus x, and it's multiplied by cos of negative x, and it's added to cos 90 plus x, and we're going to take it a little bit down to continue, but then it's multiplication. It's multiplied by cos x minus 180. Remember, this is on the same line. Okay, having it like that, we must simplify and make sure that we get one trigonometric ratio. So let's start. In here, if you look at it, we are not doing something that we don't remember, because when you reduce in grade 11, we're using this Cartesian plane with 180 plus or minus, 360 plus or minus. So we are doing that here. We're going to say 180 minus x. Where in the Cartesian plane I'm going to find 180 minus x? It is on the second quadrant. Is it sign positive or negative? My sign is positive, so that is going to be just sine x. And you multiply it by cos. Remember, folks, negative angle is in the fourth quadrant, and in the fourth quadrant, cos is positive. That Cartesian plane, some people call it cast, some people call it many other things. So maybe we can try to draw it here and remind ourselves about it. This is cast, and my student says all silly teachers complain, and some says all student to copy, and some student, one of my students say allow students to copy, especially maths, because they are failing it. So if we allow them to copy, they can get it right. So this is the slogans you can try to use and remember what you are saying. Whatever works for you, you can use it. So when I say sign is positive, I'm talking about where is in the second quadrant. This is the quadrant I'm talking about. So that is why we ended up with the sign x. Remember, we say this is where 0 is, this is where 90 is, and that is 180, and that's 270. Then we end up with 360. Okay, so the minus is here. 180 minus is on the second quadrant. Now, the fourth quadrant has the negative x. That is why we are saying the cos will simply be a positive cos of x. Okay, folks? Let's go to the third one. Okay, they said plus. Cos 90 plus x. Now, cos 90 plus x, it has a partner. The moment it is starting talking about 90 and 270, it's married. Now it's talking with the other partner, which is now sine. If it's just cos, remember cos, if we call it fully, it's cosine. So if it's sine, it means its partner is going to be cos. If it's cos, it means they are together. Now it's cosine. They're now married. Now we have that cosine. You need to take the wife and leave the husband, the cos. You use the sine. So it means that we are going to use sine. However, while using the sine, we have to look at the fact that where do we find cos and where do we find 90 plus? Remember, 90 plus is on the second quadrant. And on the second quadrant, only sine is positive. Cos is going to be negative. That makes our sign here to be a negative sign. So you need to be careful of this. You need to take note of it because it's very important and it can make you lose marks. And now, look at the last one. That is cos x minus 180. We are used to 180 plus 180 minus. But we can break that because it's just what we are used to. We can still make something out of it. Let's see. If I have x minus 180 and then I rearrange it, I'll have negative 180 plus x. If I take out the common factor, I'll have negative 180 minus x. Can you see if I multiply this, I'll go back to what I have. So it means what we are going to do with this is actually this part. Okay, so we're going to put our cos, put a negative, and also the angle 180 minus x. Remember, folks, negative is in fourth quadrant. Then that means cos is going to be positive. So that is your first statement. You will have cos of 180 minus x. You can write it within the statement, but sometimes there's no need for you to. You can do it aside. Then having it like this, we go to the second quadrant where cos is negative. So this has become negative cos x. Do not confuse this information. It's very important for you to be enlightened about it. So we are going to multiply this with a negative cos of x. And that is our first part of simplification. Then we start multiplying out the negative. This is sine x times cos x. The negative times a negative will give me a positive. So we remain with positive sine x times cos x. Now, if you look at it, we have cos x, sine x, sine x. It's like we are having x and x, if you look at it like that. So we can add them together, for which we'll have 2 sine x cos x. Now, 2 sine x cos x is written in your formula sheet to say this is the double angle of a sine. So you can write it as sine of 2x. Can you see now? You have your single trigonometric ratio. And then that's where you'll get your full marks in total. Okay. Let's see if there's another question for this one. I guess that was the last question for this. And it was 6 marks. Look at it. It's just as small as it's just that this information must be inside your head for you to be able to get this full 6 marks. Okay, thank you, folks. Okay, matrix, we still continue with the revision of trigonometry. And a similar question has been selected as well. But now this one is a diagram with a Cartesian plane with 2 lines from the origin. And some other information is given to you. So it's still in question 5. So let's write the question. It's question number 5. And it is given as such. 5.1, they're saying P, it is minus the square root of 7 and 3. And S is A and B are points on a Cartesian plane. As shown in the diagram below, P angle OR is equals to P angle OS. And they're all equals to theta. And OS is equals to 6. So let's try to draw this diagram, and then we can start working on what they want. I'm going to draw it along the side. It is in this manner. That's where your P is, which is minus the square root of 7 and 3. This is where your other point is, which is S with A and B. Remember, we're given that this is 6, and then the angle that is moving from there to there is theta, while we are told that also the angle between there to there is another theta. Okay, they said they are equal, so that's what we are having in there. There's a point R given to us. Okay, let's see. Now, when it's like this, it has been given to you. What is important now, it is the instruction. What are they saying? Determine without using a calculator. So whatever you do, a calculator is not part of the solution here. You have to do something to get to the solution. Now, remember, folks, we said, if you are given something on the Cartesian plane, you must create your right angle triangle. That is your first step. So our right angle triangle, our first one will be the one that we construct from P, perpendicular to x-axis, and try to locate the information given to us. Look at it. The negative square root of 7 is our x there, so we can put it there, and 3, it is our y there. What are we looking for? Our r. So r is not there. We need to find r. In this case, to find r, we use Pythagoras theorem, and that is always the case. Now the other one, it is this line there. We can construct it and make it perpendicular to the x-axis. The A is going to be on the x, and the B is going to be on the y. So those are our 2 diagrams that are given to us. They are not intersecting in any way because they are not equal in size. And that is the important part of it. Don't make them equal because they are not. It's not up to scale, but you must make sure that they are not equal and try to put every information. Immediately before you look at the question, try to find the missing side if you can. And now that missing side can be found if 2 sides is given in Pythagoras theorem. Okay, let's find the one for here. It's r squared equals x squared plus y squared. Our x is negative the square root of 7, so we square that, plus 3 squared. That is our r squared. Okay, but our r will be the square root of, then we put a negative 7 squared will give us a 7, and then a 3 squared will give us a 9. So we add them together, will give us 16. And that means that r will be equals to 4, because the square root of 16 is the same as 4. So it means that your missing thing there, it's now 4. Okay, now for that matter, it means now you can move away and start looking at the question. Now the trick is you must allocate all the information given to in a diagram before you can start looking at the question, so that don't get confused, right? Then after here you go to the question. 5.1 says find tan theta. It's going to be simple because now you have everything needed. So that is our 5.1.1. We must find tan theta. So tan theta, therefore, it's going to be, because remember tan is opposite over adjacent using a soccer to a slogan. So it's going to be tan theta, it is opposite over adjacent. Remember the adjacent we're talking about here is for the negative, the square root of 7, not the a. So we're going to say negative 3 divided by the square root of 7. And now that is your tan theta. Then they give you 1 mark. Can you see how simple that can be? It's not that bad for you to get that mark. It's very simple. And don't worry, this one will get marked somewhere on the road. Just that they had these two. That is why they did not give it marks for it. Okay, remember tan theta associated with x and y. That is why they didn't give you a mark. So because it's y divided by x. That is why it's like that. If you look at it, you're taking it from the statement. It's not coming from the workouts. This workout will have a mark with another question. So let's go to question 5.1.2. And 5.1.2 they say, find sign of negative theta. Interesting, and they just want you to be stuck because you will be confused just by seeing a negative theta. Folks, this is trick. All the things that you have in the trigonometry are working together, are online. Remember the negative angle on the Cartesian plane is in the 4th quadrant. So where sign is negative. So it means you're going to write this as having a negative sine theta. And then you look for sine theta to find a solution. What is sine theta then? Sine theta is opposite over hypotenuse. Now if you look at this one, it has 3 marks. Can you see that some marks will be coming for this one? Because by doing that can give you 3 marks. So it's going to be opposite over hypotenuse, meaning that it's going to be negative 3 divided by 4. Now this is where you get your marks. One will be saying, can I get 3 marks just by doing this? No. Other mark is coming for you who have been doing this. Because now you are using the 4, and now the 4 is working there for which you have worked it out before. They will go to that part where you have write it, and they will give mark for it. You don't have to stress and say, I need to put it in line with the question. Because it's there on the same question, they will award a mark for it. You shouldn't be stressed. Okay, number 5.1.3. If we look at this question, I guess most of the learners wouldn't answer it. Because, okay, let's write it a little bit there. It's 5.1.3. Okay, 5.1.3, most of learners would leave it, but it has 4 marks. And I will understand why. Because a little bit confusing because of the question in which is structured. But let's look at it and remember the instruction. Because if you forget it, you'll do something and you'll make it wrong. They said determine without using the calculator the value of A. Now, if you are looking for the value of A there, it means now you are in this Cartesian plane. And if you are in this Cartesian plane, you are looking for A. One of the things that you know you don't know is this angle that you are dealing with. You know it as a theta from this point. So what is it that you are going to do? You have A, B, and C as a side. It means that you are going to use your Pythagoras theorem in this triangle. So this is going to be, remember this is r squared equals x squared plus y squared. And what is your value of r? Your value of r is 6. So you squared. Your value of x is what you are looking for, is A, and your value of y is B. You don't know what that is, but you have been given letters. So you write them as it is, because that's what the question wanted to do. And after that, you have to remain this side with A. So taking the b's by subtracting, that is 36 minus b squared is equals to a squared. Now you are looking for a, remember? So you have to put the square root both sides. So a will be equals to plus or minus the square root of 36 minus b squared. And one can factorize it further, you can leave it like that, but then your value of a will be associated with this. Only if the value of b was given to you, you will therefore have the actual value without anything. But because you don't know b, this is how far you can go in answering the question. Okay, folks, I get this is a little bit straightforward, and you just don't be tempted. You must make sure that you do it as it appears, and look at the relevant question that is given to you. Okay, with this Cartesian plane given to you, that question is done. So let's go to 5.2. Okay, in 5.2, they are giving us some interesting information. It is very interesting to do this thing. Okay, let's look at it. It is interesting because you have to now a little bit look at your formula sheet and try to use whatever it is that you know. So this is the question now. In the question they say simplify. Now the moment they say simplify, you need to know that you need to do something beyond what you have. It's not just the formula sheet, the factorization comes in, the substitutions of other things comes in. So what is it that we are simplifying? The expression for sine x cos x all divided by 2 sine x minus 1. And you have to simplify it to a single trigonometric ratio. If I was you, immediately when I see it like this without numbers, I will run to my formula sheet, put it in front of me, and then look at the relationship. First of all, there is something that has sine and cos in the formula sheet, but it's not 4 here. What is it? It is 2. So it means you're going to say this is the same as 2 multiplied by 2 sine x cos x. Going to the formula sheet again, you can see that there is something that can look like this one. But if you look at it in that manner, it says 2 sine squared x minus 1. 2 sine squared x minus 1, you have to rearrange it a little bit first. Let's see if we rearrange what we are going to have. A minus 1 plus 2 sine squared x. Now, if I have this, I'll have 2 times sine 2x. Because 2 sine x cos x is the same as sine 2x. So that is coming from the formula sheet, direct. But in the denominator then, I need to work out what is coming out. There I need to take out the common factor of a negative. Then I left with 1 minus 2 sine squared x. Folks, I'm doing this so that it will accommodate what is on my formula sheet, because 1 minus 2 sine squared x is the same as cos 2x. So it means I can change now this to cos 2x. I'll have a negative 2 sine 2x divided by cos 2x. Can you see I'm leading to what I want? Because according to the identities, sine of an angle divided by cos of any angle is the same as tan of that angle. So it means that sine 2 theta divided by cos 2 theta will be the same as a tan 2 theta. Okay, sorry, 2x. So you can see now I'm on my 1 ratio. I'm on my single ratio, it's just tan to x. So you need to be careful of those things and try to relate it based on your formula sheet. So this is the same as that. Change them and get your marks. Very straightforward, and you're just using the formula sheet to get them right. 3 marks, because you're not doing much, you're actually going to the formula sheet. That's why it's not that much. But it is the marks that you can grab and then make sure that you don't miss them for unnecessary reasons. Because the formula sheet is there, you're just going to it and play around it, you get to the solution. Now, there's another question they said, hence. Normally when they say hence, most of us will leave it out. Hence simply means use what you have done to do what is coming out. And now they give you something, but if you look at it, you will see that it's similarly there, just that they change at least an angle and they put a number. That's what they do. So let's see what they're saying hence to. Hence calculate the value of. So that is 5.2.2. We are calculating the value of 4 sine 15 cos 15 divided by 2 sine squared 15 minus 1. Folks, look at this. This statement is the same as this statement, just that now x is 15. There's nothing different. Now what you're going to do is you're not stressing, you're just going to go straight to the solution. That's what you do. You go straight to the solution and you're going to say this is equals to a negative 2 tan of 2 multiplied by 15. Because what does this mean is that your x has changed to become 15. And that is the meaning of hence. Take that, use that to get the solution. Then that means you have a negative 2 tan of 30. Folks, we have a special angles. If you quickly run to your special angles for 30, This is your special angle, it's a right angle triangle. So if this is 30, this is going to be 60. Remember the sum of the angles in the triangle is 180. So then 30 will have 1 there and the square root of 3. Now what is tan of 30? It is opposite over adjacent. So tan 30 there is going to be opposite of adjacent, meaning it's a 1 over the root 2. So you multiply that with 1 over the root 3. And that is negative 2 divided by root 3. Some of you will want to rationalize, and it's just going to be negative 2 the square root of 3 divided by 3. Either way, this is going to be the correct answer. So that's how we go. So you can write it like that, or you can rationalize to get to this one. And you have answered the question, and voila, you have your 2 marks for the hands instead of leaving it out. Okay, folks, that is the last question of question 5, and then thank you. I guess this will help you. Okay, grade 12s, we are continuing with trigonometric revision, and now we are looking at another question which normally we had challenges when we come to it, but I think we will solve that now as we are doing this one. Okay, looking at this question, it says, it just said straightforward. Still question 4, question 5, as we said that these questions are usually in question 5. So it's still question 5, and they're saying if x is equals to 3 sine theta and y is equals to 3 cos theta, determine the value of x squared plus y squared. So what are you going to do? You're going to write, it is 5.1, so you're going to write x squared plus y squared is equals to. What did they say x is? They said it's 3 cos theta. Remember this is square, so you must square it. And they said y is 3, x is 3 sine theta, not cos, so this is 3 sine theta. Okay, and we are adding 3 cos theta from the given information, and we squared. Now we need to work that out until we reach where they want us to be. So you simplify until you cannot do anything, only on the right hand side. So let's look at this. Remember that 3 squared is giving us 9, so this is going to be 9 sine squared theta, and the 3 cos theta will give us a 9 cos squared theta. If we take out the common factor of a 9, we will have 9 multiplied by sine squared theta plus cos squared theta. This is one of the identity that says sine squared theta plus cos squared theta is equals to 1. So that's always the case. So it means we're going to change this to make it 1. So this is 9 multiplied by 1, which will be 9. Meaning that x squared plus y squared is equals to 9. And they give you a 3 marks. Can you see how direct that is? It's not difficult, straightforward. Everyone can write it in this manner. Okay, let's go to 5.2. So that is the question. Let's write it down so that we can be in the same path. It is sine of 540, and it is minus x, that's our angle, multiplied by sine of negative x minus cos of 180 degrees minus x, and multiplied by sine of 90 degrees plus x. Folks, looking at this question, you can see the variety of many things. It is 6 marks. To start with, there's 540, meaning that the revolution has been completed, and then we go to the third quadrant, and then we go again to the first quadrant and to the second quadrant again, but after the revolution. So it's 360 plus. Now what are you going to do here to split this thing to have 360 plus something to give you that particular 540? And bear in mind that you have to simplify to a single ratio. So let's do this. To get 540, I guess we can say 360 plus 180 will get 540. You can quickly check that as well, that when we say 360 plus 180 we'll get 540. Let's double check. Yes, we are getting it. So what are we going to do here? We are going to split in that way. So we have sine of 360 degrees plus 180, which gives us 540 minus x. So we didn't change anything. Actually, we are using this different bracket, so you can see that there's nothing that has changed. Now your angle is 180 minus x in this case, so it's 380 plus. Do you understand? It is in the first quadrant. Now the second one is a negative. Negative is in fourth quadrant. It means that sign is negative there. We have to take the negative out. So we are multiplying this with a negative sign x minus 180 degrees minus is on the second quadrant, where only sign is positive and cos is negative. So we're going to have it as a negative cos x. Now, we are coming to a co-ratio. Remember we said cos and sine, they are married. You see a wife sine, it means you have to introduce the cos, which is the husband. Now we have sine, it means that its co-ratio is going to be what? Cos. So we're multiplying it with cos of x. But bear in mind that we are in which quadrant? A second quadrant. Our ratio sign is positive. Therefore, this is going to be positive as well. So we are in this same bracket. Mind you, if this was cos, it means this was supposed to be a negative sign. So that's how we look at it. So this is fine for now. We need to double reduce this one. 360 plus is on the first quadrant where everything is positive. So we're going to write it as 180 minus x multiplied by a negative sign x. Use a bracket so that you don't confuse your signs. Instead of using multiplication, you therefore start using a negative to change the statement. So this negative and the negative will multiply, and that will be automatically be positive. And then you'll have cos of x multiplied by cos of x. Now let's go back to this part. We still have 180 minus. 180 minus is on the second quadrant where sign is positive. So we're going to put our sign x multiplied by the sign x. Remember there's a negative, so we're going to put our negative there so that we can remember. And there's plus cos x times cos x. If you look at it, this is sin x, we can make it sin squared x. This we can make it cos squared x. So let's do that. This is negative sin squared x plus cos squared x. If we rearrange this system, we take the cos to the first part, we'll have cos squared x minus sin squared x. See something like this, you can relate. This is in your formula sheet. If you run to it, you will find it being the double angle of cos. There's three of them. So there's cos squared alpha minus sin squared alpha in this one. So it means this is the same as cos 2x. That is your single ratio. And you know how much this is? It's 6 marks. So it means you can get free 6 marks directed and very simple. That is the end of question 5. Thank you, good talks. Okay, matrix, we're still discussing, or we're still on the revision of your matric final examination 2019. It's on trigonometry. Remember, this is paper 2 and it has more marks that you have to collect in this format. So we're going to start with some questions that are very interesting in trigonometry. These questions are always there with few marks that you all can grab. So let's start with the question. It's question number 6 for this case. This time it's in question 6. So what is it saying? Without using a calculator. Like, they like you guys not to use a calculator if you look at it. So you need to stop using a calculator too much, unless if you can use it for which we can see. So you need to make sure that the calculator is not your norm. They are saying without using a calculator, determine the following in terms of sine 36. Now, in terms of means whatever you do, whatever the answer is, but sine 36 must be there. So that is what it means. Not necessarily that the answer must be equal to sine 36, but in terms of sine 36 must be there. So let's see what is the question. And bearing in mind the sine 36 there. Question 6.1.1. We can write this sine 36 in 6.1 so that we can remember. Not that it has marks. We just want to always put it in our mind. They said find sine of 324 degrees. Now, sine 324, it is less than 360. So what you are going to do there is to use 360 minus. So sine of 360 degrees minus whatever angle that you put there must give you 324. So if you say 360 minus 36, you will get 324. And 360 minus is in the fourth quadrant, for which you have to do what? To check if sign is positive or negative. So sign is negative, that means you have a negative sign of 36. And that's what they wanted you to do to that question. The second question, 6.1.2, they say find cos of 72. 6.1.2, you are looking for cos 72 degrees. Now, how can you make cos 72 sine 36? You need to start by, remember you have to do trial and error, there and there. In this case, you have to start changing the 72 and see if it can give you 36. I think if we say 36 plus 36, it will give you a 72. Or if we say 2 times 36, you'll get a 32. So you'll have cos of 2 times 36, which gives you a 72. Now you go back to your formula sheet and check, oh, in the formula sheet I have something that is double angle, and for cos, it means that I'll have 1 minus 2 sine squared of 36. So this is the same as 1 minus 2 sine squared of 36. And you do have that sine 36 there, so that's what they want you to have as a solution. And that is about 2 marks. Now, for these two, you can see that what you need to remember is the 36, and from there, you can get it right. Okay, folks? Let's go to 6.2. And 6.2, they want you to simplify. Simplify, no, this case we are proving the identity, meaning that you have to prove that the left-hand side is equal to the right-hand side. So always they are proving, you must remember many things. If you see tan, make sure that you change your tan to sine and cos. So if you leave it as it is, it will create problems. Change your tan to sine and cos, because sine and cos, they're the simplest. You can deal with them. They have many things on the formula sheet, so you can be able to change from one point to another. So let's do that. Our equation is 1, or our identity is 1 minus tan squared of theta divided by 1 plus tan squared of theta. It must be equals to cos squared of theta. So that is your identity. In proving the identity, you must make sure that you take the complicated side, uncomplicate it until it can give you another one. Logically, so you can get it right. So let's try to do that. Let's choose our left-hand side. This is equals to 1 minus tan squared of theta divided by 1 plus tan squared of theta. Before we can do anything, I said, you see tan, you change it to sine and cos. Remember, the identity for tan is sine divided by cos. So we can say this is 1 minus a sine squared of theta divided by cos squared of theta divided by 1 plus a sine squared of theta divided by cos squared of theta. There's many divisions there, so you have to try and extend the one that is in between, such as this one, so that one can see. Okay, from there we have 1 minus, so I'm going to rewrite this as sine squared theta divided by cos squared theta, and I'll put my division there so that we don't have confusion. Remember, this is 2 terms, so we need to make it 1 term by looking at the lowest common denominator. So it's cos squared theta, and there we'll have our cos squared theta plus sine squared theta. Our identity for cos squared theta plus cos sine squared theta, it says that is equals to 1. So we are going to do that. So this is 1 minus sine squared theta divided by cos squared theta multiplied by cos squared theta divided by 1. Because when we change the division, we flip and then we multiply the right hand side of the expression. So this is what we have. These two are the same, so they can cancel. We'll remain with 1 minus sine squared of theta. And 1 minus sine squared of theta, according to our identity that says sine squared theta plus cos squared theta is equals to 1. It means that if you try to make cos squared theta the subject of the formula, you will get 1 minus sine squared theta. Therefore, that is cos squared of theta, and that will be your right hand side. So after you do that, you will tell us that this is what you have proven and is the same as your right hand side. left hand side equals right hand side, and you just get your 4 marks. Simple and straightforward. Okay, thank you.